So let's try to find C. Of course, at this moment, you might question, why don't we use find function that provided by MATLAB, right? And we are going to ignore that find function for the moment, and let's think about that we are going to implement the find function by ourselves, right? In that case, we are going to comb through from 1 to 5, right? And we are going to check it, whether it contains this character C in the cell array or not. So it means that navigating from the first to the rest until it hits. And that's actually the only way to implement our own find function, right? So our first index, x1, it contains A. It's not C, so it's false. It's no hit, right? Next, right? It's B and C, no hit. And next, right? And C, no hit because it contains D, it's no hit. And then, yeah, it contains E, no hit. And then finally, F, no hit. Means that from the first to the rest, right? From the first element to the rest element, C doesn't show up. C doesn't show up, right? It means that the only conclusion that we can make at this moment is that, right, we don't have C in this cell array. And that's the right conclusion, right? So after 5 retrievers, after searching A, B, D, E, F, we found that there will be no hit, always n retrievers, if there is no such element in that list, all right? If we want to find the D, and then in this case, A, no hit, B, no hit, yes, it's hit, right? It hit. So D is here at x3. In that case, after 3 retrievers, we found the hit. Maximum number of the retrievers can be, of course, n. If we were looking for F, in that case, we will require 5 retrievers, right? And in the case, it's going to be n retrievers. So it means the maximum n retrievers, right? And actually, it seems that it's unavoidable retrievers, right? Okay, fine, I understand that. How about this? So we want to put C. We want to insert C in between B and D. Means that this is the where C is supposed to be. Then how make things work? This moment. So we have this X and we have this 3 index to insert, and the value to insert is C, right? We want to put C here. How can we do that? So this is a short code that how we do it. So first, we are going to create a cell 1 to 6. This creates a cell array of a certain dimension. Okay, so it's 1,6 means it's 1 row and 6 columns. Means that we are going to have 1, 2, 3, 2, 3, 4, 5, and 6. And this was X. This will be Y, right? So that's what this line is doing. And then what this line does is that it has ITR, so it means that it's a for loop. It's a for loop. The second operation that we are doing. The for loop, and this index to insert is 3. Means that 3 minus 1 equals 2, right? So it's from 1 to 2. What we are going to do is that we are going to assign the X's value to the Y, right? Means that from 1, 2, 3, 4, 5, and 6 means that we are going to do this and this. This is Y1, Y2, right? And then what comes next is third instruction here, and we are going to put the reference here. So we have this C and Y IDX insert, and it's going to be 3, right? This 3, and there will be an assignment instruction here. And the fourth is that the copy the rest. It's 3, and the length of the X will be what? The 5 means that 3, 4, 5, and then X3 will be equal to Y4, and X4 will be equal to Y5, and things like that. So X3 equals Y4 means this, and this, and this. And after that, what it says is, okay, I will erase some of this for you. Okay. Right. Tricky. Okay. Okay, so this X equals Y means that, you know what, X is now going to dump this whole thing, is throw away, and the Y is going to be new X. Means that now we have A, B, C, D, E, F. We don't have G here, but anyhow, so we put C inside of this linked list, right? And C has, we have Y1, Y2, Y3, Y4, Y5, Y6, right? So the total count of the retrievers from this arrays are like this. So we have this A-1 instruction coming from this second. And here we have 1 retrievers here. And then we have N-A from the first, right? So total N number of the retrievers that we need to insert C, right? So I think that is pretty easy concept and no one will object at this moment, I think, right? You know what? We just want to input C here, but we are going through so much trouble this moment, right? And we really don't like that. Okay. And then let's move to another scenario. Let's remove D from the list, right? And first, we make, of course, a new list. New list of Y cell 1 to 5 means that 1, 2, 3. I intentionally avoid this, and 5. So it's 1, 2, 3. It's not 5, but it's going to be 4 and 5, right? So this is Y and this is X, right? And then what we do is this. First, copy the reference links from the, it's going to be 1 to A-1, right? So it's 1, 2, 3, minus 1 means 2, right? So, it's problem, right? It should be 4 to delete D here, and it's going to be 4, and it's going to be 3. And then what it does is that there is an iteration assigning the values here, the references here. So 1, 2, and 3, right? And then what it does next is that we have this 4 plus 1 means 5 to 6. And then what it does here, right, we are doing the third part, right, at this moment. And it's Y5 minus 1 equals X5, and Y6 minus 1 is X6. Right, so X5 equals Y what? 4. X6 is equals to Y5. So things like this. And then by using this statement, we are going to throw away throw away, right? There is a small garbage can, and throw X this away, and then new X is going to be Y, right? So that's the change X's reference to the Y's reference. So total count of retrievals are like this. So first we have to do this as A minus 1 iteration here, and then we have to do this N minus A iteration here. Total N minus 1 iterations, well, N minus 1 retrievals from the set array to delete D. We just wanted to delete D. We'd like to make it just one instruction, one retriever, because it's only about D. We are not going to touch A, B, C, E, F. But what happens in the set array is that we have to touch A, B, C, and E, F to just delete D. It sounds a little bit kind of uncomfortable, right? We have no business with A, B, C, and E, F. But when we want to delete D, something like that, then yeah, you have to deal with the whole set array, right? So we have and like this.